Good morning, children. So, we have got the concept of intrinsic and extrinsic semiconductor. So, if you consider the extrinsic semiconductor, then you know there are two types, P-type semiconductor and N-type semiconductor. So, if you consider a piece of P-type semiconductor, then you know in the P-type semiconductor, what kind of impurity it is? Accepted type impurities. Alright. So, each atom, each doped atom, it accept one electron from the host atom and thereby it becomes negatively charged ion. Alright. And there are, what are there? There are majority charge carriers as holes. Alright. So these are the holes. Okay. So you see what is happening when it is accepting one electron, then it itself is becoming negatively charged immobile ion and there are majority charge carrier as whole. That's why whenever there is a p-type semiconductor, we represent the p-type semiconductor like this. Means what? Inside p-type semiconductor there are negatively charged immobile ions and holes are majority charge carriers. Okay. Now, if you take a n-type semiconductor means donor type. Means it donates one electron to the host atom. So when it is donating one electron, then it itself becomes positively charged. So if you consider a n-type semiconductor, then n-type semiconductor, what is there inside? There are positively charged immobile ions, alright, within it, and there are electrons as the majority charge carrier. Electrons are the majority charge carriers. Okay. So this is the way we represent the p-type semiconductor and n-type semiconductor. Alright. I hope it is clear from the diagram. Once again I am repeating, in p-type semiconductor there are negatively charged immobile ions, holes majority charge carrier, and in n-type semiconductor positively charged immobile ions sorry and electrons are the majority charge carrier. Okay. Now, what is the name of the chapter? I said junction diode. Diode means two electrode. Alright. So, junction diode means it is electronic device. Alright. And how it is constructed? Just by joining p-type and n-type semiconductor together in such a manner that when you are joining them, there is no deformation across their boundaries. So, this is known as the PN junction diode. Diode means two electrodes. So, you see as if P region is the one electrode and N region representing another electrode. Alright. Now, the moment you are joining the P and N type semiconductor together, then you see what will happen. Holes are the majority charge carrier in the P region. Concentration of holes is more in the P region, whereas concentration of electron is more in the N region. So what will happen? These electrons, they will try to move to the P region and they will cross the junction, and holes also, they will try to move through the junction. Alright. So, as a result, what will happen? That the first layers of hole and electron, they will cross the junction and they will recombine with each other and they will be lost. Here one important point you must remember, that when an electron and hole recombine, both of them are lost because electrons and holes, they are oppositely charged and they are having the same amount of charge. Okay. So, you see, the moment they are diffusing each other, so you see what is happening. the holes, the first layer of hole and first layer of electron, they have crossed the junction, recombined and lost. So here this region, this layer, there will be a positively charged immobile ion layer on the n-type region and negatively charged immobile ion layer on the p-type region. Means it will just produce an internal electric field in this direction, EI. Okay, from positive to negative, and this layer, this dotted portion where there is no majority charge carrier, that is known as depletion region. Alright, so you have to understand that whenever a p-type and n-type semiconductor are joined together, then what will happen? The first layer of hole and electron, they will cross the junction and they will be lost. As a result, a depletion region will produce. So due to the depletion region, you see an electric field will develop. So a potential barrier will develop across the junction. Alright, now connecting the p-type region to a positive terminal of a battery and the n region to the negative terminal of a battery is known as biasing. Alright, what is biasing? Biasing means joining the p region to high potential and joining the n region to low potential. That is known as biasing. Means just connecting a battery across the junction diode is known as biasing. And when the p region is connected to the positive terminal of the battery and n region connected to the negative terminal of the battery, then it is known as forward biasing. Alright. So you see, the moment forward biasing is there, so you see an external electric field, it is acting in this direction, external electric field E. So what will happen? Holes under the action of this electric field, it will cross the junction, isn't it? And the electron, it will move to opposite to this. So you see what will happen? The moment you are connecting them, then holes and electrons again start crossing the junction. Alright, now what will happen? That you have to understand. When the hole will move from p region to n region, there will be a what I can say, concentration of hole in the p region will decrease. Alright, so concentration of hole in the p region will decrease. Then what will happen? Here in this region, at this end, the end which is near the battery, what will happen? Covalent bond will break. And when covalent bond will break, an electron hole pair will be produced. Is that clear? So here I am saying it verbally because it will take lot of time to note it down on the board. So please you note down every point. I am discussing it slowly, one by one, point wise. You please note it down. So first point, what you will write? The moment P region is connected to the positive terminal, N region connected to the negative terminal of a battery, holes from the P region will move to N region and electrons from the N region will move to the P region. They will cross the junction, recombine and lost. First point. Second point is, due to this, concentration of hole will decrease in the P region. What is the second point? Concentration of hole will decrease in the P region. Alright. Then third point. As a result, covalent bond will break at this end, near the battery end of P region. What I said, third point, covalent bond will break at the end, battery end of P region and electron hole pair will be produced. I repeat, what is the third point? That when the concentration of hole will decrease in the P region, covalent bond will break at the battery end and electron hole pair will be produced. Alright. Now, when the electron hole pair will be produced, then holes will stay back within the P region and will increase the concentration of hole, or will try to keep the concentration of hole constant at the P region, but the extra electron, they will come out and move to the positive terminal of the battery. Alright, so you see what is happening, that in the P region, although due to diffusion under the action of the battery, the concentration of hole will decrease, 3 hole decreases, then 3 covalent bond will be broken, 3 electron hole pair will be produced, 3 electron will come out, and 3 will be within the P region, keeping the hole concentration constant. Now, come to this one. What is happening here? It is losing the electron, isn't it? Three electrons just diffuse from N region to P region and lost. So what will happen? Here it will just extract 3 electron from the negative terminal of the battery, and it will regain the concentration of electron. So you see, it is so nice that here it is losing 3 hole, 3 covalent bond broken, 3 hole it get back, 3 electron coming out. It has lost 3 electron. It is just extracting the 3 electron from the negative terminal. So you see, outside the circuit there will be the flow of electron as shown in the diagram, and inside there will be flow of electron as well as hole. So as a result, in the outer circuit, what you will get? You will get an electric current. So when the PN junction diode is forward biased, then we get current in the outer circuit. Alright, I hope everybody noted down the physics behind it point wise as I discussed. Then the next concept is coming, concept of reverse biasing. So here one more point you have to remember, that when the PN junction diode is forward biased, due to the movement of majority charge carrier, we are getting the current in the circuit. Alright, due to movement of majority charge carrier. Hole is the majority charge carrier in P region and electron is the majority charge carrier in N region. So due to movement of majority charge carrier, you will get current in the circuit when the junction diode is forward biased. Alright, then next is, now if the PN junction diode is connected to a battery in such a manner that P region is connected to the negative terminal of a battery, N region is connected to a positive terminal of the battery, then it is known as reverse biasing. This is known as reverse biasing, and the diode is known as reversed biased diode. So under the reverse biasing condition, you see what is happening. Just look at this, the external electric field, it is increasing the depletion layer and increase width of the depletion layer and height of the potential barrier. Okay, when it was forward bias, then forward biasing battery, it decreases the depletion region and height of the potential barrier. But in case of reverse bias, what is it will do? What the external applied field will do? It will increase the width of the depletion region and height of the potential barrier. So what will happen? Holes will not be able to diffuse to N region and electrons will not be able to diffuse to P region under the application of the external electric field. So you see what will happen, that when the junction diode is reverse biased, then majority charge carrier won't be able to diffuse through the junction. Alright, but if you consider the minority charge carrier, in the P region, minority charge carrier is electron. So you see, electron, it will move under the action of the external electric field from P to N region, and in the N region, holes are the minority charge carrier. So minority charge carrier will move through the junction, and due to diffusion of minority charge carrier, what will happen? A very small amount of current will be obtained. Negligible amount of current will be obtained in the external circuit. So we say that when a junction diode is reverse biased, it never conduct electricity, and when a junction diode is forward biased, it can conduct electricity. And this property of the junction diode only used for rectifying a circuit. Okay. So you have to remember what is the forward biasing. Forward biasing means P region is at higher potential, higher positive potential, and N region is at lower negative potential. So if you consider a PN junction diode, then the symbol for PN junction diode is this. Alright. This arrow, you see it is looking almost arrow. This is the P region, this is P region, and this bar is the N region. Alright. So what is the symbol for PN junction diode? This is the symbol for PN junction diode. Okay. Because we have seen that when the junction diode is forward biased, current always flow from P to N region and this way. You have seen no electrons are moving in this direction. What does it mean? Current will flow in the opposite direction when it was forward biased. Now, if you consider a PN junction diode and if you consider this thing, suppose it is at minus 2 volt and this is at minus 3 volt. Then both the P and N region, it is connected to the negative potential. Do you think that it is not forward biased? Yes, it is forward biased. Why? Just look at the diagram. This P region, it is less negative, more positive, and N region is more negative. What does it mean? That when P region is at higher positive potential, then also the diode is forward biased. So this is a forward biased PN junction diode. Now, if you consider this one, that suppose this is plus 5 volt and this is plus 3 volt. Both are positive, but P region is plus 5 and N is plus 3. What does it mean? That it is at that P region, it is at high potential and N region, it is at low potential, low positive potential. So it is a forward biasing. Then if you consider this one, that this is 0, this is connected to the ground. So this is 0 volt and this is plus 5 volt. Then also it is forward biased. Why? Because P region is at high positive potential. Alright. Then if you consider this, that P region is connected to the ground and it is at minus 2 volt. So P region connected to ground means it is positive potential 0 and it is negative. So this is also forward biasing. So forward biasing, what is the sense? That P region should be at positive potential, positive higher potential, and N region should be at low potential. Then that is known as forward biasing. Alright, and under the forward biasing condition, the diode conduct electricity. It allows electricity to pass through the circuit. Now next concept is forward biased characteristic circuit and V versus I graph. So forward biased characteristics circuit means you want to, under the forward biasing condition, how the current varies with the potential applied across the diode, that is known as the characteristics circuit and the graph. Alright. So you see, never try to mug up the circuit. Alright. So how I am drawing the circuit and what are the essential apparatus needed for that, how to join them, just try to understand. So what I said, what is the characteristics circuit and graph? You have to vary the current as well as potential applied across the diode. So you need, first, you see what you need. First you need a PN junction diode. Then you need an ammeter to measure the current. Then you need a voltmeter to measure the potential difference. And then you need a potential gradient. Potential gradient means what? The device through which we can change the potential applied. So potential gradient is nothing but a variable resistance connected with a battery. You see, this is a variable resistance. So this is the one terminal and this is one terminal. Alright. So you see how to connect. PN junction diode, first the ammeter should be connected in series with it. Then voltmeter should be connected parallel with it. Yes or not? Then what will happen? One end you connect it to this variable point, other end you connect to the potential divider. So this is the circuit diagram for the characteristics graph. Now if you look at this, you see this is the positive terminal. Now if I start from the positive terminal, follow my finger, how it is coming here, then going here, then coming here. So it is connected to P region. Positive terminal connected to P region, negative terminal connected to N region. That's why it is a forward biased characteristics circuit. This is the circuit diagram for forward biased characteristics. Now, in the forward biased characteristics, the current is in the order of milliampere. That's why we, instead of taking an ammeter, we take a milliammeter. Small m a means what? We take a milliammeter. So you see, this is positive terminal. So this terminal should be positive, this terminal should be negative. And you know how to make the connection for voltmeter. Positive terminal of the voltmeter should be connected to the positive terminal of the battery. Negative terminal should be connected to the negative terminal of the battery. So you see, this is the proper understanding of the circuit diagram, how to draw the circuit diagram. Never try to mug up, and if you want to try to mug up, then definitely while vomiting, there will be garbage and you won't be able to. So understand the physics behind it. Okay, I am repeating for characteristics current. You have to measure current and you have to measure the potential difference. So new in ammeter, voltmeter, how to connect ammeter in series, voltmeter in parallel to PN junction diode. Okay, then next point is you need to vary the current as well as the applied potential. How you can do it? By using a potential divider. So this is a potential divider, a battery connected with a variable resistance, and it has two terminals. This is the variable terminal and this is the fixed terminal. So this is the circuit connection for forward biased characteristics graph. Now if you draw the forward biased characteristics graph, then here you plot V along the x-axis and current along y-axis. Okay, so you will observe that when the forward, I hope you can remember in the forward biasing condition, I am just showing it. This is the depletion region. Depletion region is in this direction, and this is P and this is N. And when you are just joining the battery is, what it is doing? It is decreasing the depletion region. So until and unless it can totally decrease the depletion region, the majority charge carrier won't be able to diffuse. So you see what will happen when you are increasing the applied potential, means you are increasing the applied potential across the junction diode, then you will see the current will become 0 for certain time. Then the current will increase like this, forming a knee here. This is known as knee. This point correspond to that. At this point, the applied potential is able to break the potential barrier across the junction completely, and the majority charge carrier start diffusing. And as a result, you see current increases manifold. Alright. So you see here that current versus potential graph, it is not obeying the Ohm's law. Okay, it is not a straight line. So in this case, this is the non-ohmic resistor. Junction diode, it is a non-ohmic resistor, and this is the characteristics graph of the forward bias junction diode. Now for exam, what is important? This diagram as well as this graph is very, very important. So you must practice the circuit diagram as well as the forward biased characteristics graph. Next is coming reversed biased characteristics circuit and the corresponding characteristics graph. Alright, so reversed bias means, you see P should be connected to the negative terminal. So what you have to do? In the potential divider, you just change the battery connection. Then you see what is happening. Negative is connected to the P region. So it is reverse biased. Now, in case of reverse bias condition, when I have discussed, due to the movement of minority charge carrier, we get negligible amount of current in the outer circuit. That's why instead of a milliammeter, we have to take a microammeter, not milliammeter. Milliammeter we take for forward bias, because under the movement of majority charge carrier we get the current, so current is higher. But in reverse bias condition, current is negligible, so we just take a microammeter, because if you take a milliammeter or ammeter, it won't be able to detect that small current. Now, another point, you see here the ammeter and voltmeter connection you have to change. Why? Because now this will be negative terminal of the voltmeter and this will be positive terminal of the voltmeter. Like that, this should be negative terminal of the ammeter and this should be positive terminal of the ammeter. Alright. So you see here the potential is in the opposite direction. Current also we will get in the opposite direction, isn't it? So, if you consider the reverse bias characteristics graph, then potential is negative, current is also negative. Is that clear? So, that's why the reverse bias characteristics graph we get in the third quadrant. I hope you can remember, in the third quadrant, both x and y are negative. Now, in this case, you see what will happen. The moment you will increase the applied potential, then under the action of the minority charge carrier, you will get a very small amount of current. Alright, and then when all the minority charge carrier will cross the junction and start flowing, then you will get a reverse bias saturation current. Just look at it, the current is almost constant. Look at it, current is almost constant. Alright, now in this way, if you go on increasing the potential applied, then what will happen? Due to the increased potential across the junction, applied across the junction, suddenly a large number of covalent bond will break across the junction. Where the covalent bond will break? Across the junction. And as a result, suddenly a large number of electron hole pair will be produced. This is known as avalanche. Avalanche, I hope you can remember, this is the phenomena in geography. So due to the sudden avalanche of flow of electron, what we will observe that the current increases manifold, but potential is not increasing very high, but the current start increasing. So this is known as Zener breakdown or avalanche. Okay, this is known as Zener breakdown. Means when the applied reverse biasing voltage crosses certain limit, then what happens? A large number of covalent bond break across the junction diode, across the junction of the diode. As a result, avalanche of electrons start flowing through the external circuit and the current increases suddenly, although potential is not increasing by a large amount, but current increases by large amount. So this is this point here where the current start increasing. This is known as the Zener breakdown. Okay, or the voltage is known as breakdown voltage, and this is the nature of the reverse bias characteristics graph. Okay, means what? Due to the minority charge carrier, the current is, you see the amount of current so small and current is saturated. You just look at this one, it is almost parallel, so current is saturated. But here when the background happen, then current again will increase manifold. Okay, so this is the circuit diagram for reverse bias characteristics graph, as well as that is the graph for reverse biasing condition. These two circuit diagram and these two graphs are very, very important. You must practice both the diagram and both the graphs. Thank you, children.